Hi, I'm Jim Anderton, Technical Editor of SSGM Magazine. I'm in Midtown Toronto at Victor's Tire and Automotive Centre talking about some Gates products we're going to install on this 1997 Ford F-150. This vehicle has a rotating electrical problem, specifically an alternator issue, and we're going to change the alternator. However, to get to the alternator, of course, we're going to remove the drive belt. Now, the alternator can't produce electricity if it's not being spun reliably by the engine. This, of course, requires the drive belt system, and I speak of a system because it really is more than just a belt. In this case, in this 1997 vehicle with a 4.2-liter V6 engine, this vehicle has multiple pulleys, multiple accessories driven by the belt through a tensioner assembly and through an idler pulley. We're going to replace the idler pulley and the tensioner assembly as well as the belt to do justice to this new alternator and give this vehicle reliability and quiet running. We're going to be installing a Micro V AT belt, and we'll be showing you one of the ways that belts can wear and the fact that belts can wear or can deteriorate in ways that are not visible to the naked eye. Let's get started. Step one, the belt's off. Old belt, new belt. What's the difference? Well, it's more than just color, and unfortunately it's not a visual thing that you can do anymore involving cuts or splits in the belt. This belt appears to be just fine visually. However, it's actually worn out, and I'm going to show you how to check that. This small indicator tool makes it easy to check the state of wear of these belts. The old belt is on the right. Notice when I drop the indicator gauge inside, it drops down below the level of the top of the ribs, right down to the bottom. This tool is bottoming out in the trench or the valley between the ribs. On the new belt, notice how it rides up proud. The reason is simple. The V's are worn on the old belt. In this case, it's bottoming out inside the grooves. The load is actually carried by the sides or the flanks of the V's in the groove. So although this belt looks fine, no splits, no tears, no cuts, it's worn out. It's not adequately driving all the accessories in this hard-working truck. The belt looks fine, but it has to be replaced. Essential that we explain this to consumers who are used to a world of V-belts. They're looking for cuts, tears, or obvious signs of abrasion. The belt looks good, but it's no good, and it's got to be replaced. I've just removed this idler pulley with a very long Torx bolt and a lot of finger dexterity. And you know what? When I've taken it off, I've discovered noise. Bearing is worn out in this idler pulley. You could not tell that with the engine running externally because of engine noise and because of the howling of the failing bearings in the alternator itself. The bearing has not yet got to the point where we can detect axial play on the pivot bolt, but it's noisy, it's dry, it's on the way out. You're crazy not to install a new replacement idler pulley if you're doing a belt drive system in an application like this. It's low-cost insurance. It will add customer satisfaction. We're ready for reassembly now. I'm about to install the belt tensioner first. This tensioner locates the reaction forces as the twisting forces against the tensioner spring against these two lugs. But for that to work correctly, this has got to fit flush against its mating face. This is nice and shiny and clean, but you better believe the mating face at the other end, the aluminum casting, is rough and corroded. So of course we're going to go in there, we're going to clean it off before we reinstall this thing. This has got to sit tight and flush to work properly. And by the magic of video, the new idler pulley, the new tensioner is installed, torqued to spec and ready to go. This is the old belt. This is gone. We're going to install a new belt. But one thing I like to do if we're going to install a new belt is think about these. We've used these nitrile gloves to handle some fairly greasy, dirty parts in here, and they're saturated, contaminated with solvents, anti-seize, and oil. Why would I want to contaminate this lovely brand new belt with this stuff and generate more trouble in the future? So I'm going to switch to fresh nitrile gloves to install this new belt. I'm installing the new belt now, fresh nitrile gloves. Everything's clean, everything's ready to go. Pulleys have been checked for alignment. They look great, bearings are great. We have new idler pulley, new tensioner. We're ready to go. One more thing here, routing, belt routing. There's more than one way to route a belt. In most cases, it's self-evident which way it goes. Some ways there are ways to accidentally misroute it, but still get a functioning part, but outside the operable spec or the operating range for the tensioner. This is a bad thing. There's a belt routing sticker, of course, on the cowl of this car, or on the splash panel here, like there is in every other car. There's also a service manual to tell you how to route this thing. There's also common sense. I'm going to use all three and make sure I've got this thing routed correctly. We're done installing a Gates idler pulley, Gates tensioner, and Gates belt on this 4.2 F-150. We used this small gauge to determine that the old belt was worn and needed replacing. We didn't use this. If you need to use something like this to get a belt on over an idler and over a tensioner, you're doing something wrong. Check the routing, check if you installed the parts correctly. There's no reason to ever use one of these for quality belt installation, but there's always a reason to use one of these.